Yeah, Sandri, can you hear me? Okay, yeah. We'll start by 4:20, but what I want you to do, I think, would allow you to mute your mic so that you can ask your questions. So it's going to be more of those areas that you find challenging. So I'll try and give, help or aid you to understand those areas that you are finding challenging. So that's what we just prepare your questions or maybe concerns as we wait for 4:20. Hope that's good. Okay, I think we can begin instead of just stalling a bit. I hope you can hear me. Sandre, please give, give me a thumbs up if you could hear me. All right, good. So we want to start so that we can cover a lot of things. Now, preparation for the exams, we have the syllabus already on the screen, meaning that these are the areas where likely the questions will likely be coming out from. All right. Of course, at the closing stages of the paper, there is always a question on organic chemistry. All right. It's always organic chemistry. A few questions. This particular part of the syllabus has very few questions. That's chemistry of the environment, where you're basically just asked the composition of air, test for water, or maybe you asked to um, talk about greenhouse gases. So very few questions are always from here, right? Very few marks are always allocated to this section. Then we also have metals where, of course, you could be asked to describe the bonding of a metal. So to describe a metallic bond, these are things you need to revise. Okay, describing a metallic bond has to do with you talking about the regular pattern or in which the cations are arranged. The metallic bond has a lot of cations with a pattern. There is a pattern to which these cations appear. So you have to talk about first that it has a lattice of positive ions arranged in a lattice, or we could say arranged in a regular pattern. And also, if you also want to describe the metallic bond, you also have to add that there are electrons surrounding this, the localized electrons surrounding the positive ions. And then you also have to talk about the fact that these electrons are held together by what we call electrostatic force of attraction. So basically, you have to go and look at the metallic bond, how to describe a metallic bond. Remember, there are three things. It's always a three-marker question. So you should be able to tell us that there are positive ions arranged in a pattern. And these positive ions are surrounded by delocalized electrons. And then the delocalized electrons are held together by electrostatic force of attraction. So very important. Review that so in case there's a question there. And then also under metals, we talk about the uses of aluminium. Why is aluminium used to package food materials? Of course, it's because it is resistant to corrosion. And then other metals like copper, okay, and other metals that you could read under the syllabus. So that is for metals. I hope you can still hear me. Yeah, please send me a thumbs up if you can still hear me clearly. Soundray, are you there? Can you hear me? All right, good. I hope you prepare your questions right. So I just want to run through the syllabus and then I will entertain your concern because that's your luck for attending the class, the free class. You have access to asking uh, challenging questions or things you don't understand. Okay, apart from the metals, I'm just going an overview. Okay, do you already have the syllabus? So apart from talking about metals, we also have the periodic table. Of course, periodic table, you talk about the group one. Okay, you talk about the halogens, and then you talk about the transition metals. So the ability to compare all of these, especially the group one versus the transition element, is important. Look at their physical properties, look at the chemical properties, and when you also get to the halogens, you have to look at the properties, the physical properties, the states of the halogens. If it's fluorine, chlorine, bromine, iodine, okay, astatine, and tennessine. You have to look at their physical properties. How do they appear, basically, and also look at the trend in their properties, especially physical properties. When we talk about the boiling and melting point, we also talk about reactivities of this element. These are things you should review before you go into the examination. Very, very important. It's an extremely important idea. All right, and that's majorly for the periodic table. So those are basic things. Then you know the properties of transition elements, their physical properties, talk about their high densities, okay, talk about their high melting point and boiling point. Then you also look at their chemical properties, which has to do with the tendency for them to form colored ions or colored compounds. They also use as catalysts. So these are things you need to brush through before you go into the exams. And then we have acid, bases, and salts. That's topic 7. For the acid, bases, and salts, of course, you need to know the difference between the dissociation of a strong acid versus a weak acid. So you have to be able to tell how a strong acid dissociates and how a weak acid dissociates. For example, H2SO4 is a strong acid. Therefore, okay, I think I should use a clear blank page so I don't have to overload that page. So, for example, you want to look at sulfuric acid as a strong acid when it is dissociating. All right, you are looking at the hydrogen ions, and then so this is the proton. An acid is a proton donor, basically. So acids are proton donor. So this is the acid donating the proton. Okay, so this is a strong acid because the dissociation is complete in water. So it's a complete dissociation. And how do you represent that? You represent that using this one directional arrow. However, if it's a weak acid, if you want to show how it is dissociating, so we have a weak acid. So if it's going to dissociate, for example, your ethanoic acid, if it's dissociating, you're going to have a reversible arrow to represent that. And of course, you're going to have the anion. You're going to have the proton, which is, so you can see the difference now that this is weak acid dissociation because you can see it's partially dissociated or it doesn't dissociate completely in water. But for strong acids, they dissociate completely in water. So that is one thing you need to be careful about when you're asked to represent a complete dissociation for a strong acid and a partial dissociation for a weak acid. Okay. Now, apart from the dissociations, you also need to look at the pH, how you know a strong acid, how you know a weak acid, looking at the pH scale. So for strong acid, you're looking at from pH of 1 to, I think, you say 4. And then for the weak acid, you're looking at pH of 5 to 6, basically. So look at the pH, and then you also need to consider the use of indicators. So when we talk about indicators, how do the acids and how do the bases respond to indicators? And also, you should also be able to tell the difference between a base and an alkali. Okay, so a base is a substance that can react with an acid to form salt and water. So this can react with an acid to form a salt and water. But an alkali is a base that is soluble. So an alkali is a soluble base, meaning not all bases are soluble. So the base, any base that you find that is soluble in water precisely, we refer to such bases as an alkali. Okay, and there are strong alkalis and there are weak alkalis. So strong alkali, sodium hydroxide, is a strong alkali, meaning it completely dissociates to produce the hydroxide ion. Then we have the weak alkalis like ammonia, which will dissociate partially. Okay, so these are things that are very important when you're revising these things. And then you have the salt formation. Basically, when we talk about salt formation, we are looking at the acid-base reactions, okay, or we could also have acid metal to form a salt. All right, so we have the acid base, we have the acid metal. These are reactions that can, give you the salt. So we're going to quickly look at something under the salt, which is also very important. So we have different reactions that can produce a salt. We have the neutralization reaction, basically, that's a popular one. So we talk about salt. You have your neutralization, and from the word neutralization, it's actually dealing with an acid plus an alkali or base to give salt plus water. So in this kind of a reaction, of course, you produce a salt. So you can be asked to give the ionic equation for this reaction. So a question could ask you, show the ionic equation of this reaction. So the ionic equation of the neutralization reaction is simply H plus, that is the acid donating the proton, plus the hydroxide to give water. So this is the ionic equation for neutralization. I think a couple of years this was asked. So you have to note the general, or we say the ionic equation for neutralization. So when you form the salt, of course, you know that in your salt formation, you could also have acid plus metal. That would also give you salt. This is more of a displacement reaction. You have the salt plus hydrogen gas. So this is another way to form your salt. You could also form a salt by doing the acid plus metal oxide. This will also give you salt and water. And then you could also have a reaction of an acid and a metal carbonate. So this will also give you salts. But this will have one more product. So you give you water, and you would have also carbon dioxide. So I'm also going to form carbon dioxide because of the carbonate present here. So these are the reactions that, excuse me, that can give you the formation of a salt. Now, what am I driving to? What I'm driving to is, after you obtain the salt, a question could ask you how you obtain the salt. Okay, how you prepare the salt. So before you learn salt preparation, you should know that there are two categories of salt. So the salts, there are two types basically. There is the soluble salt and there is the insoluble salt. So these are the two types of salt that you need to be conversant with. Now, for the soluble salt, you can produce the soluble salt using neutralization. Basically, you can use neutralization to produce the soluble salt. You can also use the acid plus metal method to produce the soluble salt. You can use the acid plus metal oxide method to produce the soluble salt. But when you get to the insoluble salt, there is only one method that is adoptable, and that is precipitation. Right, so this is the only method we use to prepare an insoluble salt. We could use these other methods to prepare soluble, but when we get to insoluble, there is only one method. And what does precipitation mean? We're going to be adding two soluble salts together. You're going to have two soluble salts, you mix them together, and then you form an insoluble salt. So that is what precipitation is all about. Now, let's go through these things now. When you prepare a salt if you prepare a soluble salt, of course, you should know that soluble salts, you could go through the process of heating to point of crystallization. All right. But insoluble salt, you do not heat when you're trying to prepare an insoluble salt. You basically just stir, and then the salt will precipitate out. So know the difference between the preparation of a soluble salt and an insoluble salt. And I just stated that just as a form of summary, that in a soluble salt, you can heat to point of crystallization to obtain crystals of the soluble salt. But for insoluble salt, there is no need to heat. What you just need to do is to turn your two soluble salts into solutions and mix them together, and then the soluble salt will precipitate out. Okay, so let's go through how do you know a salt is soluble and how do you know a salt is insoluble. Now, there are solubility rules that you should also be able to quickly get a grasp of. Now, for the solubility rules, there is a rule that says there's a mnemonic we call SNAP. SNAP. Now, what does SNAP mean? It means sodium, S for sodium, N stands for nitrate, A stands for ammonium, and P stands for potassium. Now, what does this mean? It means all of these salts are soluble. They are soluble. So this is one way to remember your soluble salt, SNAP. All sodium, any salt that contains sodium, for example, sodium chloride is a soluble salt. Any salt that contains nitrate, for example, sodium nitrate is a soluble salt. Any salt that contains ammonium chloride is a soluble salt. Any salt that contains potassium is a soluble salt. So SNAP helps you pick your soluble salt. It has to fall within any of these categories. Let me get your feedback. Hope you can still hear me. If somebody is on the meeting room.
Do we need to learn the valences for each compound?
I didn't get that, sorry.
Do we need to learn the valences for each compound? The oxidation state?
Yeah, I'm going to give you a quick way to learn the valences. It's easy. Valence is very easy for the elements. Since you'll be given the periodic table, there is an easy way to look at the valences. So what I do is this: if the salt is if the compound, sorry, the elements rather, if it's in group one, it has a valency of +1. Simple. Group one +1. Group two would have +2. Group three would have +3. Group four would have +4, or we say -4 in some cases. Group five would have -3. Group six would have -2. You can see it's dropping now. Group seven would have -1, while group eight would have 0. So it's very easy. Group one +1, group two +2, group three +3, just like that. And then when you get to group four, it starts dropping. So this is how you know the valences. I hope I've been able to help you do that. So just know the group, and then you'll be able to detect it. All right, so that is for the question on the valency of this element. So pick the element and then you know it. Of course, there are what we call compound ions, or we call them complex ions. Like this now is a compound ion. This is a compound ion. Okay, this one you just need to memorize how they appear. And there are several others like that, like the carbonates, okay, the hydroxides. These are compound ions. All right, so that is for this is how you get to know balances. Just follow it. Group one +1, group two +2, like that, and you would remember. All right, so I was talking about salt preparation. So I was saying that for you to know salts that are soluble, SNAP is the easier way to know it. So sodium, S for sodium, N for nitrate, A for ammonium, P for potassium. So it's as simple as that. So if you're asked to pick a soluble salt, just pick it from this category. Pick it from SNAP. Very easy. Just pick a salt that contains sodium. It's definitely soluble. Or pick a salt that contains nitrate. It is definitely soluble. Or pick a salt that contains ammonium. It is definitely soluble. Or you pick one that is in potassium group and it is equally soluble. That is what we have to do for this. Of course, this video is going to be made available. All right. So we just move to the next part of it because I want us to entertain more questions from you. All right. So going forward, apart from SNAP, there are other categories of salts we need to look at. For example, chlorides. Not all chloride salts are soluble. Not all chlorides are soluble. And these are the chlorides that are not soluble. So how do we know then? We use PAR. Okay, PAR. So PAR means P for lead. So lead chloride is not soluble. Silver chloride is not soluble. Mercury 2 chloride is not soluble. So any salt that has any chloride that has lead, silver, and mercury, they are not soluble. However, other chlorides are soluble. But as long as they contain lead, they contain silver, or they contain mercury, they are not soluble. This is very important because we're giving a list, maybe in your multiple choice questions, and you ask which one is a soluble salt there. So once you know these rules, it helps you. Now let's go to sulfates. Not all the sulfates are soluble. Okay, when we talk about sulfates, I'm talking about SO42 minus. Not all the sulfate salts are soluble. So how do we know this? PCB, lead. Any salt that has lead 2 sulfates is not soluble. Calcium sulfate, not soluble. Barium sulfate, not soluble. So these are the sulfates that are not soluble. All right. So every other sulfate is soluble, but anyone that has lead, calcium, or barium is insoluble. All right. And then finally, we just talk about the carbonates so that we can move. So with carbonates, not all carbonates are soluble. So the ones that are soluble are just from the SNAP. Okay, so SAP, call it SAP, SAP. So we get the soluble carbonate from, remember all of these are insoluble. So you don't make the error. This is insoluble. But when we get to carbonate, we have SAP. SAP is, like we said, sodium, gotten from SNAP, ammonium, and potassium. That is, all carbonates are not soluble except these ones. These ones are the soluble carbonates. So when you are asked to prepare an insoluble salt, you know where to pick your soluble salt from. Like I said, you pick them from SNAP. Or if it's more complicated, you have to know the chloride, sulfates, and the carbonates, basically. So that is for this. And also, under this, remember I said for the soluble salts, you do not heat. You just mix the two soluble salts together, you filter, you wash, okay, and then you dry. It's straightforward for insoluble salt. Just mix them together, mix the two soluble salts you want to mix, filter the mixture because, of course, when you mix them together, it will precipitate out. So you filter. After filtering, the next thing is you wash with distilled water and then you dry. It's just simple. But for the soluble salt, then there is a need for you to heat to points of crystallization. So the difference between the soluble and insoluble is when you're preparing a soluble salt, crystals, of course, you heat. But when you're doing insoluble salt, you do not heat. Right? So that's the difference between two of them. Now, for example, another question could say, okay, we're trying to produce insoluble salts, lead sulfate. Write the unique equation for the formation of this. So this is simple. Just split this into ions. There's no need to write, sometimes you have to write spectator ions. There's no need to do all of those stories to save yourself the time. So split this. How do you split this? This becomes Pb2 plus, this becomes SO42 minus. This is how you write them in your ionic state. So split them into ions. Then when you've done this, the next thing is to write the ionic equation now. So we start with Pb2 plus in the aqueous form, plus the second species, the sulfate ion in the aqueous form, and then your lead sulfate in the solid form. So this is how you write the ionic equation for the preparation of insoluble salts. All right, so I'll hold on and ask for feedback. Feedback questions basically on what I've said so far on the salt preparation, or maybe general questions you might have regarding this topic. Okay, I want to assume there are no questions. Awu Rama, can you hear me?
Hello.
Yeah, I can hear you.
Can you give a brief description on moles?
I didn't get that, sorry.
A brief description on moles, biochemistry.
I find it hard to hear you. So maybe you change your location or just take it slowly.
So, sir, I think he's talking about description of mole, if I'm to get that correctly. Is that what you're saying?
Yes.
Okay, all right. Well, we're going to get there. Okay, move description. Abu Rama, I hope you can hear us. If you have
Yes,
your
please.
questions, all right. If you
No,
have your
please.
questions, yeah. If you have a question at 5 p.m., I'm going to entertain questions. I just want to run through the syllabus again.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the EdExcel and Cambridge IGCSE. And yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about and the fee is really quite affordable. Really, it's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E-levels as well, and also for the EdXL. So we have for the Cambridge E-levels and EdXL E-levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to E-level, mathematics and chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for E-level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com and they'll reply to you.
Okay, so we're going to talk about more concepts as we progress. Okay, so back to the syllabus. We have done the salt preparation of the thing. I just want to talk about that. So now, chemical reaction, under chemical reaction, it's important that you look at rate of reaction. Very important. How does temperature affect the rate of the reaction? Okay, very important. All right, and it's a 3-marker question. So when you actually explain how temperature affects the rate of reaction, you talk about the kinetic energy of the particles, you talk about the increase in the frequency of collision, you talk about that there are more particles with energy equal or greater than the activation energy. You see these questions in the past papers a lot. How does temperature affect rates of reaction most times? Okay, or if it's concentration, you have to describe how concentration affects the rate of reaction. Of course, you have to talk about the increase in the particles per unit volume. You talk about the frequency of collision as well, increase in it, and then you talk about the rate of reaction increasing. So chemical reaction just has to do with you looking at the rate of reaction, the factors that affect the rate of reaction, and interpreting the rate of reaction curve, whether it's increasing rate or decreasing rate. All right, so that is something you need to look at. It's also important because there's always a question of rate of reaction. Then for topic 5, we talk about chemical energetics. For energetics, we talk about your exothermic and endothermic reactions, basically. Okay, and we also look at equilibrium. Right, we look at how the Chatelain's principle, what are the factors that affect equilibrium. We talk about temperature, we talk about pressure, and we talk about concentration. So you have to be able to understand how each of these affects equilibrium, whether temperature, pressure, or concentration, especially temperature and pressure. Okay, for temperature, we look at if the forward reaction is exothermic or endothermic. That is how you determine the direction of the equilibrium shift. Is the forward reaction exothermic or is it endothermic? For pressure, you are looking at the number of gaseous moles on the reactant and product. So there are 2 things you need to be careful of. For temperature, you look at, is it exothermic? Is the forward reaction exothermic or endothermic? That will determine your conclusion regarding the equilibrium shift. But for pressure, you would look at how many gaseous moles are on the reactant end and how many gaseous moles are on the product end. Then you use that to determine. So note that difference in using each of these factors. Okay, so of course you should also know the energy profile diagram. How do you know something, a reaction is endothermic or exothermic? Then also there is bond energy calculations. Okay, calculation of bond energies, calculation using bond energies rather to get the enthalpy. also very important, where you have your change in enthalpy to be equal to the energy you need to break minus the energy you need to make. So you have to know this formula and how to use it. There are questions in past papers that talks about that. All right, and then also for your chemical energetics, you know that the catalyst does not affect the equilibrium position. And then we go to electrochemistry, where of course you have to look at what electrolysis is all about, what is the definition of electrolysis, and then you look at the different kinds of electrolytic solutions. Okay, when we talk about the melting states, you have your melting states, you have your concentrated aqueous state, and then you have your dilute aqueous state. So you have to know the difference in the ions that are migrating to the cathode and anode at these three different electrolytic solutions. For the melting state, of course, you just heat it, it melts, and then the cathode is negative, so the cations will go there, and then the anions will go to the anode. But for the concentrated aqueous, we say there is more of the ionic compound, concentration of ionic compound is more. And then for dilute aqueous, we say there is less ionic compound, or we could say there is more water here. You have more water present in the dilute aqueous. For the concentrated aqueous, you have less water. Okay, so these are things you need to factor in when you are determining what migrates to the cathode or the anode. We'll talk about that if there are questions from that angle. Okay, then I want to talk about stoichiometry last. So states of matter, of course, that's one of the most easiest part of the syllabus. Talk about the arrangements of the solids, the particles, the liquids, and the gases. Talk about their shapes and other things. Those are basic questions there. And then atoms, elements, and compounds. Yes, you have to look at bonding, especially. It's a definite question there. It could be ionic bonding. It could be covalent bonding. You should know what an ionic bond is. You should know what a covalent bond is. You should know how to calculate percentage composition, and also be able to perform calculations on empirical and molecular formulas. That's what you're going to look out for. And then one of the easiest questions there, which is to look at calculating the number of protons, neutrons, and electrons in a neutral atom and in a charged atom, basically. So these are things you should expect for atoms, elements, and compounds, and you need to look at and review it. Okay, and then we have stoichiometry. Of course, I've not talked about this. I'm going to look at that also. Stoichiometry revision. So let's review it, just like Sandra has requested. So let's revise stoichiometry. For stoichiometry, all you need is formulas. All right, formulas. So you need to have your formula well aligned in your memory. Okay, so there is a formula you use when you're dealing with solids. Okay, if there is a solid involved in the question, you know that the number of moles is mass over ml. That's for solids. But if the question is on, let's say, liquids or solutions, let's say solutions now, you know that your number of moles is concentration in mole per dm cube times volume in dm cube. So always ensure that you have your volume in dm cube, and then you have your concentration, of course, which is always given in mole per dm cube. If your volume is not in dm cube, you divide by 1,000, because the conversion is 1,000 cm cube equals to 1 dm cube. So just convert if it's not given. Also, under solutions, there's another formula you also need to know, which is concentration in gram per dm cube. And what you have to do here is you get your concentration in mole per dm cube, and you multiply by the MR, molecular mass of the compound you are dealing with. So these are the two formulas that apply to solutions. So any of them that you have to do, you have to note these formulas. And then there is also the formula for gases, because for the gases, you know your number of moles is simply the volume of the gas given of gas divided by 24 dm cube. That's the volume at RTP, molar volume at RTP. Of course, if you want your answer to be in cm cube, your formula will become 24,000. Just multiply by 1,000, basically. So that's for gases. Okay, so how many formulas do we have? We have formula 1, we have formula 2, formula 3, Formula 4. All right, and then the fifth formula is where you have particles, question on particles or ions or molecules or atoms, either of these. Okay, so you know that your number of moles is equal to number of ions or particles or whatever you have to find, whether it be molecules or atoms, divided by Avogadro's constant, which is 6.02 times 10 to the power 23. So these are the formulas, this is formula 5 that you need to know. So when you know all of these formulas, you can solve a question on stoichiometry. So 1, 2, 3, 4, 5. Like I said, 5 formulas are things you need to put in when you're asked to solve the question on stoichiometry. And hopefully, maybe when I entertain your questions, we might solve a typical question where we apply some of these formulas depending on the kind of question. The question wants us to apply maybe 2 or 3 of them, would put it in. But we'll get to the question and answer section, we'll talk about that. So finally, for the syllabus, we look at experimental techniques. For experimental techniques, we are looking at tests for ions. Okay, your test for gases. Of course, we're not going to have a lot of questions there. It's very few questions from this angle, except when you're doing your paper 6 or you're taking paper 5. Now, for this, of course, you should be able to, for paper 6, you have no problem because you'll be given all of this information. You'll be given the chemical analysis of each of those ions. But for paper 4 or paper 2, you need to be able to, know some of these ions offhand. Just by looking at their colors, you can also use that to determine. So that is for the experimental technique. So look at colors. You want to learn them based on colors. For example, white precipitates are going to be having calcium, aluminium, or zinc. Those are the things you give you white. So when you talk about blue, you say copper 2. So when you look at brown or reddish brown, you look at ion 3. So categorize these ions into colors, and then you'll be able to remember them for paper 4. So this is where I would bring this summary so that I can entertain questions, weaknesses. You can take your questions, take what concerns that you have, and then hopefully we'll see how far we could go. So this is the time for questions. Let's see how we can also do some past papers on any of your questions. So if you have a question, please, you can unmute your mic and ask. Ajiro Tech, please, can you make it possible for them to unmute and ask the questions?
Yes, they have the permission to do that.
Okay. Yeah. All right, so are there questions you want to ask? This is the time for it.
No other question.
Okay, the other member of the class, any questions? Amurama, you have a question? Okay, so let's solve a past paper since I think we're good. So let's solve a couple of questions.
A lot, and you're like, okay, do you have a private tuition? Don't you have? Do you have? And yes, Ajiro Tech do have a private tuition. So by my right, you can see that we have for the Edexcel and Cambridge IGCSE, and yes, we do have for all subjects. Okay, all subjects. Okay, the popular ones that's always been in demand is mathematics, English language as a second language. Okay, we have physics, we have biology, we have chemistry, and we have the flagship, which is ICT, just here and there. We also have business studies. So if you're interested for a private tuition, I think all you have to do is send an email to the sales team at ajirotech@gmail.com, and they would reply to you, talk about your time zone, talk about and the fee is really quite affordable. It's really quite affordable. It's when you look at it across other tutoring service, I think this is the one that's quite affordable and you get the very best of service. We also have for the E levels as well, and also for the Edexcel. So we have for the Cambridge E levels and Edexcel E levels. Okay, and we have also across the subject mathematics, which is usually the hot cake when it comes to A level. Math is N, chemistry, and then biology. These are usually one of the ones we have in demand always, all the time, even physics, for A level. So all you have to do, if you're watching this right now and you are interested for a private tuition, then you can do yourself a solid, okay, and send an email to the sales team at ajiro@gmail.com, and they'll reply to you.
Just to revise our knowledge. This is a February, March, basically 2025 paper. I'm trying to do something more recent so that you have a view of what. So let's pick something from what Sandre asked. Let's go to the stoichiometry part of this question. Let's see. Stoichiometry. All right, so we have a question here, stoichiometry. Yeah, so this is a question. So we'll solve this together. All right, so this is a question there. It says, we have a reaction with dilute hydrochloric acid as shown. So we have an equation for this. Now it says calculate the volume of chlorine gas formed in cm cube at RTP when excess of this react with, okay, so you have the volume and concentration. So now the first question says calculate the number of moles of hydrochloric acid used. Now if you look at the number of moles of hydrochloric acid used, remember what I said? Think of the formulas you have already. Where does this one apply? Does it apply to a solid? Does it apply to a solution? Does it apply to a gas? Or does it apply to particles? You will agree with me that acid here is a solution, because in the question you're giving the volume of the solution. Volume of hydrochloric acid is 50 centimeter cube. Concentration of the acid is 0.200 mole per dm cube. So this is obviously a solution. Then you go back to your formula sheet, right, which you have already put in place in preparation for this. So look at this now. We know we're dealing with solutions. That means this is the formula I have to make use of. Formula 2 on my list of formulas. So you can see the reason why you need to have your formulas handy so that you could easily switch. Okay, so now we have our formula to be N equals to CV. Now, you have to be careful here because the volume is in cm cube. So you need to work the volume in dm cube. And I told you that one way to work the volume in dm cube is to divide the volume by 1000. So I'm going to basically use my calculator here now to divide the volume so that we can see what it is. So I'm going to do 50 divided by 1000 over here. I'm having 0.05. So my volume in dm cube is 0.05 dm cube. So this is my volume in dm cube. Now I can apply the formula. So N now will be 0.200 times 0.05. So by the time I do that, multiply that together, I have 0.01. So it's very easy. And that gets me the mark for that particular one. All right, go to the next question. Determine the number of moles of chlorine formed. Now, I go back to my question. The question says chlorine is a gas, right? Chlorine is a gas, meaning I should use the formula that pertains to gases. Let's go back to our formula sheet again. Remember what I said, when you're looking for gas, what do you say? Number of moles equals to volume over 24 dm cube. All right, and we have to find the number of moles of the gas. So this is the formula that pertains to a gas. Now, we have to find the number of moles. The question we need to ask ourselves is, do we have the volume of the gas? If you check the question, is there volume of gas given there? No, we do not have the volume of the gas. Meaning we cannot use this formula in this case because we do not have the volume of the gas. So we do not have we do not have a tangible information about the gas. So we cannot adopt this formula. So what are we going to do? We're going to use the known values to get the unknown. Since we are looking for number of moles, easy. We know the number of moles of hydrochloric acid. Can we compare it with chlorine and do a mole ratio? Yes, we can. So let's write it out. We know that of hydrochloric acid, which was calculated, but we don't know that of chlorine. Now, the next thing is after putting them into ratios like this, you have a known. What's the mole ratio of them on that equation? Chlorine has 4, so 4 ratio. What is chlorine? Chlorine has 1 in front of it. Okay. Now, you calculated the number of moles of hydrochloric acid in the previous step, which is what? 0.01. So if you know that chlorine is 0.01, so if you know that hydrochloric acid is 0.01, what is chlorine? So represented as X. So basically, this is the method you use whenever you do not have a lot of information about the other species or reactant or product. So if chlorine, if they have a ratio of 4:1, and one of them is 0.01, what is the other one? So we can cross multiply here. So we cross multiply, we're going to have 4x equals to 0.01. Then we divide by 4 to get x. So x will now become, so I'm going to divide this by 4 using my calculator, and I'm going to have my answer as 0.0025. So this is the number of moles of chlorine. I use the known to get the unknown. So this is the pattern of questions. You always have to use a known to get the unknown. So get used to this pattern. And the final part of this stoichiometry now says calculate the volume of chlorine formed. Now that I have the number of moles of chlorine, I can get the volume. Remember the formula is N equals to V over 24. But the question says my volume must be in cm cube. So I'll change my 24 dm cube to cm cube. So it's going to become, instead of 24 dm cube, it's going to become 24,000 cm cube. Just multiply 24 by 1,000. So that's 24,000 cm cube. So I want to look for V. V is unknown. So V will be number of moles. Number of moles is already here. So 0.0025 times 24,000. So by the time I do this now, I'll multiply this by 24,000. I have 60 centimeter cube. And that solves the problem of stoichiometry. So you can see that stoichiometry is very easy if you know what you do, if you know the formulas, and then you know when to use the formulas. So that is basically how stoichiometry works. All right, so let's see. Of course, I told you I'm going to have a question on experimental technique. This is just one question. I also told you I'm going to have some questions on how temperature affects the rate of reaction. You can see. So there is a pattern to all of these things. You practice enough, you will be able to do all of this. Okay, so at this point, I believe since we said we don't have any questions, that means we are prepared. And you can see something on transition elements. So I believe we are prepared. However, if you have a question, I can still entertain. But if there are no other questions, what we can basically do is, since you're on the Discord channel, you post your questions there, and I will respond to it. Right? If while practicing you have any questions, just post it there. I will respond to them. So, are there any other questions that you want me to deal with? Okay. So, yeah, Sandri. Okay, good. Abraham, are you good?
Yes.
Abraham.
Yes,
All right,
please.
and yeah, Ajiro Tech. I think you also advertise that there is private tutoring. If you're interested in private tutoring, where we can take more time in looking at your challenge. Maybe you're too shy to talk about it here. Of course, Ajiro Tech would give you the process involved in going for the private tutoring. So at this moment, I want to appreciate you guys for coming into the class, and I want to wish you guys all the best in the upcoming exams. I wish you A-stars of a very strong score. All right, Ajiro Tech, over to you.
Thank you. Thank you, sir. Thank you so much for the time. So we're expecting the whole crowd here, but habits we have to plunge ahead for it. So definitely just like what Gideon said, the private tutoring is there if you want to have fun with it, enroll. It's good, and essentially, private tutoring is the way we do it is kind of different because we walk you through. If you're doing, we have a full course, where we walk you through the whole chemistry from beginning till you write your people 2, people 4, and people 6. So the full course. I think I'm currently doing that for a student right now in ICT, full course, people 1, people 2, and people 3. So we do that as well. We do a full course, Yeah, so that's the full course, that we do. Anyway, when it comes to chemistry, the tutor is there with you till you drop the last pen, So all this is just creating a platform and an opportunity for you to, to have that confidence across all your subjects. So let your friends know, maybe they're not here to partake of this free session. Maybe they want a private session. You can let them know that it's happening here. We also enroll students for private tutoring across every subject, not just chemistry, every subject. All right. So thank you so much. Okay. Same time. Bye for now.